Hey, it's Bob Duffy with Intel here with another insightful episode of TechCraft. And today we're going to go through AI denoising for 3D rendering applications. So I'm excited. We're going to do it on the... What? No, not the A770. This? Are you sure? Okay. Well, we're going to do AI denoising for 3D rendering applications on this guy, the MSI Prestige 16 with an Intel Core Ultra processor and built-in Intel Arc GPU. So it should be fun. And maybe we'll throw in the A770 if we got time.
Yes, we are going to run AI denoising for 3D rendering on an Intel Core Ultra laptop in Blender using Intel Open Denoise. Now, before we get into the demo, I've got to give you guys some background on denoising. If you feel you already know all this stuff, feel free to go ahead and scrub forward till you see Blender in the UI. But for everybody else, let's go to school on denoising. Okay, let's discuss denoising, what it is, how it speeds up the time of ray tracing, and how the Intel Open Denoise uses advanced methods to decrease rendering speeds with quality output. Most modern 3D render engines use a form of ray tracing called path tracing to create beautifully realistic renders. Path tracing works by mimicking light, shooting virtual light rays from each pixel location in an image to objects in a virtual scene. If an object is translucent, then the ray will pass and bend through the object to objects behind it. Information on light, shadows, color, and surface properties of each object along the path defines the color and the luminance of the pixel. Each light ray per pixel is called a sample. In this image, we have 32 virtual rays for every single pixel. Fewer samples or rays per pixel will result in a grainy and noisy image, but with faster rendering times. To get pristine renders, it may take thousands of samples per pixel, or even take hours per frame to generate. Denoising is a computer algorithm that cleans up the noise when using a lower sample per pixel count. This can create beautiful clean renders in a fraction of the time. Historically, many denoisers did a fair job, but in areas of low light or textures, denoisers often created unwelcome patterns in a final render. The Intel Open Denoise library uses artificial intelligence to more intelligently denoise a render, and the results can be stunning. The Intel Open Denoise library has been part of Blender for many years now, but now it supports GPU compute for rendering, allowing users with either Intel Arc discrete GPUs as well as Intel Core Ultra processors with built-in Intel Arc GPUs to use Open Denoise. Learn more about Intel Open Denoise at openimagedenoise.org. Okay, here we are back in Blender, and we got to do the basic stuff we always do in Blender. So for GPU rendering, first go to Edit, and you want to go to Preferences. And we're going to be doing GPU rendering here with Open Denoise. So select Preferences there, go to System, and that's where you can select one API, and you can select your Intel Arc GPU, and then you're going to want to select Embry for faster rendering as well, which is also for GPU. So now we're going to take full advantage of our Intel Arc GPU on our Core Ultra here. So this is a laptop that I'm going to use, my virtual laptop, to demonstrate this. Other couple of things you do is make sure over in render properties, you are using the Cycles render engine. Otherwise, we're not ray tracing. And then your device is set to GPU. Even though that we did it before, we got to do it here too. Okay, now under the viewport side, you've got a denoise option here. And you want to have that turned on and make sure that you've got Open Denoise selected. And then the new thing is use GPU, which now allows you to use the GPU for that denoise compute. And you can do the same thing under the render setting as well. So you have render settings and viewport settings for denoising. But I think what I'm going to do is let me turn off the GPU and the denoising. So I'm going to just turn everything off. And we're going to see what the experience is without denoising. So I'm going to move around the scene, and you can see it's just noisy. It's just constant noise. Samples are going up, and it's still noisy. We can let those samples go up, hit a high number, and it's still really, really, really noisy. And this is why we do denoising in here, in order to clean that up and speed up our renders. So let's go ahead and turn it on. But let's leave it to CPU, and you can see right away it's working. All that noise is cleaned up, but at first it's a little funky looking, and the sample count is really slow. So we're doing CPU denoising for all of those samples and ray bounces that are happening, and that's at a cost, to do that. Um, but before I turn on a GPU, just notice the sample count as it goes up. It's going up quite slowly here, right? Right. But let me go ahead and turn GPU on, and you'll see, wow, look at that. Look at that go up. So you can see that we are computing that denoising much faster. We're getting more of those rays, more of those samples per pixel up faster. So we're getting a crisper, cleaner render along the way. And we're doing all of this on an Intel Core Ultra processor with built-in Intel Arc GPU. Pretty cool. Okay, so what I thought I'd do is show you path tracing visualized. So we did denoising here, but here's a game board scene I've shown before here. And let me go ahead and turn on the render view in the viewport here so you can see that this is path tracing. I like this because we have this glass game piece here, so the light's refracting through it, so those rays are actually doing those virtual bounces. And you can see it is actually bending that light. But what I can do is go down to the index of refraction. I'm going to change this down to 1, which is going to make it just like clear and transparent, like it's invisible. But if I change that number a little bit, you can actually see the rays bending in near real time. So this is a really good example of actually seeing path tracing work on a device like this, an Intel Core Ultra with built-in Intel Arc GPU. Okay, before we get to the last bit and give the A770 a go, let's give some context on scaling this denoising compute for Intel Arc GPUs. With Intel Core Ultra, you experience the built-in Intel Arc GPU providing graphics processing with 8 Xe cores for lower power mobile devices like the MSI Prestige 16 AI PC laptop. And then here we're going to see the Intel Arc A770 GPU with 32 cores, which supports more demanding gaming and creator workloads on desktop systems. Okay, as I said, we're going to try this also on the Intel Arc A770. So same exact scene here. So I've got this set where, let me just make sure, yeah, denoising is off, GPU is off. So we're just doing exactly the same thing. And I'm going to go ahead and turn on the render. And you can see right away, geez, look at those samples going up. I mean, that theme went lickety split, right? So obviously a more powerful GPU. So this is scaling. So, but what I want to do is the same exact thing. Is let me turn on denoise for CPU denoising, and you can see it slows down quite a bit. So again, this is it. Just without denoising, and still we have a lot of noise. And then I turn on denoising. Now the CPU is denoising as every sample that gets generated. Now I'm going to go ahead and turn on GPU denoising. We see that is much faster. So it's definitely the same type of situation that if you don't have any denoising going on, you've got a lot of noise in the scene. But obviously, because we're scaling up with, more Xe cores, this is happening faster. But as I turn on denoise, CPU is in the process of getting in front of all of those samples, and then if I turn on GPU, that is much faster. And this is a small scene. There's only 48,000 triangles in this scene here. But what I love about Blender is we can do two things at once. So I've got Blender also open over here. This is a very different scene. We've got 8 million triangles in this scene. So this is the barbershop scene from blender.org. And I'm going to go ahead and we'll do the same thing. So we've got denoising off. We're going to go ahead and we're going to do GPU rendering here. And you see, it's going through it. It's going pretty fast, but there's a lot more geometry for all of those virtual light rays to bounce around in order to calculate the luminosity color of every single pixel here. So it's working. In fact, we can, also just jump right in here. Let me frame this. You can see this is a glass object here. So path tracing is working away, but a very grainy image, obviously. So what we can do is turn on denoise. Now we're doing CPU denoising, which is typically what we've been able to do. And the sample count is going up. It's actually pretty good, and we're getting a nice render. And this is the great thing about viewport rendering with cycles is you get to see the actual lighting, shadows, all that kind of stuff. All the shaders are being calculated in near real time. But let's go ahead and turn on GPU. And there we go, a much faster experience than what we had there before. So this is the value of what's happening with software from Intel like Open Denoise. These things are continuing to improve. Our partnerships out in the ecosystem like Blender in getting Intel Open Denoise out there with advancements that support things like GPU denoising. So there you go. Beautiful renders here on an Intel Arc A770, as well as the Intel Core Ultra with built-in Intel Arc GPU. Hopefully you like this video. More things to come on this channel, so please like and subscribe. Until next time, I'm Bob Duffy, and we'll catch you later.